All right, let's get into it. So if you're a developer using AI, you already know the dream, right? You want this seamless Copilot that just turns your ideas into perfect code. But let's be honest, the reality is often, well, a lot more frustrating. In this explainer, we're going to unpack a super powerful playbook from AI educator Matt Pocock that will totally change how you work with your AI coding assistant.
You know the feeling, right? You start a brand new chat, and the AI is brilliant. It's a genius. But then, as the conversation goes on, as you keep adding more and more context, it starts making these silly rookie mistakes. It almost feels like it's getting dumber and dumber. So what is actually going on here?
And this is the huge disconnect. The promise was this specs-to-code paradise, where you'd write a simple document and poof, a whole app appears. The reality, as Matt Pocock points out, is that this just doesn't work. We get stuck in this frustrating loop, endlessly fixing specs and fighting with the AI, when we should be focusing on the code itself.
Yeah, we can call this whole thing the AI frustration loop. It's that cycle of getting your hopes up only to see the results get worse and worse, until you feel like you're fighting the tool instead of working with it. But what if I told you the problem isn't actually the AI?
That's right. The problem isn't some bug in the system. It's a flaw in our own mental model and how we think the AI works. You see, large language models operate under a couple of really weird, really specific rules. And once you get them, really get them, everything changes.
So let's get to the absolute core of this playbook. There are two fundamental rules that you need to burn into your brain if you want to master your AI Copilot.
Okay, rule number one is all about the smart zone. Think of it like this. Every single piece of information, every token you add to the chat makes it exponentially harder for the AI to keep track of everything. It's like trying to pay attention to 1,000 conversations at once. So even if you have a massive million-token context window, after about 100,000 tokens or so, the AI's reasoning ability just falls off a cliff. It enters the dumb zone. And that means the key is to size our tasks to stay inside that sweet spot, that smart zone. Rule number two is what Matt Pocock calls the memento analogy. It's brilliant. An LLM has absolutely no persistent memory. Zero. Every single time you clear the context and start a new chat, it's a hard reset. It completely forgets everything that came before, just like the main character from the movie Memento. It just snaps back to its original programming with no clue who you are or what you just talked about.
And this really shows the huge mindset shift we need to make. Instead of seeing this total amnesia as a bug, we need to see it as a feature. A predictable, clean slate is something we can actually work with. It's a consistent starting point we can use to our advantage every single time.
Okay, so if the AI has a tiny smart zone and the memory of a goldfish, how in the world are we supposed to build big, complex features? The answer is, you have to stop delegating the thinking. You have to start leading the process with a structured two-phase plan. This human-led planning phase really comes down to two main skills. First, you have to align on the goal using a technique called Grill Me. And second, you break down the work into what are called vertical slices. Let's take a look at each one.
Now, the Grill Me skill is absolutely crucial, and its purpose is not what you might think. You're basically telling the AI to interview you, to grill you relentlessly about your idea. It'll ask question after question. But the goal isn't to get some perfect written-out plan. The goal is for you and the AI to build a shared design concept, to get on the exact same wavelength. You've got to have alignment before you can even think about execution.
Next up, we plan the actual work. If you just let an AI do its thing, it loves the code horizontally. It'll build the entire database layer, then the whole API layer, and then finally the UI. The problem? You don't get any real feedback until the very end when it's too late. The much better way is to use vertical slices or tracer bullets. Each task is a thin slice of real functionality that cuts through all the layers of the app, giving you something you can actually test and get feedback on right away. So once you have that plan, a plan built from all these testable vertical slices, well, this is where it gets really cool. This is where you can actually step away from your keyboard, or AFK, and let an automated agent take over and do the heavy lifting.
A great way to think about this is like a day shift and a night shift. Your job, the human's job, is the day shift. That's all the high-level thinking, the planning, the designing, the architecting. You line up all the work. Then you hand it off to the night shift, the AI agent, to just tirelessly execute that plan while you're off doing other things.
So how does this AI agent actually work so well on its own? It uses a classic method called test-driven development, or TDD. It's a simple, powerful loop. First, red. The agent writes a test that it knows will fail. Then, green. It writes the absolute minimum amount of code to make that test pass. And finally, refactor. It cleans everything up. This methodical process makes it way harder for the AI to cheat and helps it systematically build a really robust, well-tested codebase.
So when you step back and look at this whole workflow, what's the bigger picture here? Well, it completely elevates your role. You stop being just a coder writing boilerplate. You start spending your time thinking like an architect, designing the systems that the AI will then go and build.
And a huge part of that architect thinking is building what are called deep modules. See, a code base that's full of shallow modules, tons of tiny files with messy, complex connections, that's an absolute nightmare for an AI to navigate. But deep modules are the opposite. They have simple, clean interfaces on the outside that hide a lot of the complex stuff on the inside. They are way, way easier for an agent to understand, to test, and to work with effectively.
So your new job description starts to look a little different. First, you design the beautiful, simple interfaces for these deep modules. Then, you delegate the messy implementation to the AI. After that, you QA the work, not just for bugs, but to add your unique human taste and product sense. And maybe most importantly, your job is to build those high-quality feedback loops, like great tests, that allow the AI to do its best work.
And this really is the bottom line. The quality of your AI's work is directly capped by the quality of your own code base. An AI agent can't work miracles in a messy, untestable system. If you have a garbage code base, you are gonna get garbage out. It's that simple. Your job as an architect is to create an environment where the agent can actually win. So as AI gets better and better at just writing the code, what becomes our most critical human skill? Is it our ability to design the architecture, to build the feedback systems, or is it, ultimately, applying that uniquely human sense of what makes a product truly great, that elusive quality we call taste? Something to think about.